Hello, Neuro Club. I'm honored to present to you this presentation here involving eye movements and just a marvelous system that we have. And it's incredible the potential that we've got to help patients using various eye movement strategies and visual stimulation. So I've done my best to put together a presentation that is an hour long and give you some basic anatomy information on really which parts of the brain are involved in different types of stimulation, and also give you an overview of how the Focus Builder app can be used therapeutically. So it was kind of a challenge because it's so much information wrapped up into an hour. So I did not go into great depth, but I think it should give you a really great overview and a great starting point. So enjoy. So in the Focus Builder app, we have the ability to create various therapeutic strategies to stimulate the brain. And the greatest thing about the visual system and the oculomotor system is that you can tap into every region of the brain using this system. So therapeutically, we can use visual stimulation or we can use oculomotor stimulation. Oculomotor meaning we would use eye movements to stimulate parts of the brain versus just getting a visual stimulation that doesn't include moving the eyes. Okay, so we get those two options. Now, in order to use therapeutic eye movements or visual stimulation to benefit our patients, it's good to have a good understanding of the anatomy involved. And so I'll give you just a basic overview of the anatomy involved in eye movements. And so let's take a look here, first of all, at the brain. You'll see here that we've got the brainstem below here. And it's especially important to understand the relationship of the sympathetic and parasympathetic system when you do eye movements, because you will affect them in a positive or a negative way if you don't do it properly. So most importantly, we want to be aware of the autonomic nervous system. Okay, so we'll look at the brainstem, and then we'll also look at strategies here that affect the cortex of the brain and the cerebellum on each side. All right, so let's take a look at the brainstem first. The brainstem here in this diagram is separated by a red section and a white section. Okay, so the red section is your midbrain or your mesencephalon, and that's good to know because the midbrain drives your sympathetic nervous system. And the pons and medulla, which is where the pontomedullary reticular formation is, really activate the parasympathetic system. Okay, so really important to understand this. Now, the involvement of the cortex with this sympathetic and parasympathetic system, the cortex of the brain is very much involved in modulating those two. You can't have a highly functioning sympathetic system and a highly engaged parasympathetic at the same time. Your brain's got to pick one to prefer over the other, and ideally, it's the parasympathetic most of the time. But unfortunately, our population is one that tends to be very stress-driven. There's a lot of stress in our lives, and our ability to handle that stress is not so great. And the difference between someone who has a brain that can handle stress well is not the amount of stress that they have, but really how their brain can handle that stress. And the key element here is that in the pons and medulla here, we've got a system called the pontomedullary reticular formation. We've got that on the right and we've got that on the left, PMRF, okay? If you've got a healthy, well-functioning PMRF both on the right and the left side, chances are your ability to handle stress is much, much better. So with patients, this is an important concept to teach them. So clinically, this is very important. So it's really, really good to start here. Now, here's a few things that you need to know about the PMRF. Some of the signs of a deficient PMRF is you will see that you will have less joint stability on that same side of your body. Okay, less joint stability. You also have weakness in your distal extensor muscles. So this would be like the extensors of your fingers, extensors of your toes on that same side. Okay, so let's clear the page for a second here. Now let's take a look at the involvement of the brain as a whole and its relationship with the PMRF. So I mentioned earlier that, let's take a look at the left PMRS, that you need to have a good balance between the midbrain and the pontomedullary reticular formation in order to modulate the autonomic system well. Well, the left PMRF gets input directly from the left cortex. So the left cortex, when it's working well, will send information into this ipsilateral PMRF. And part of what's essential to grasp here is that if you have a hemisphericity or you have a deficiency in the left brain, then there's a good probability that the PMRF on the same side will not be receiving the amount of input that it requires. And it will also, it could eventually lead to a deficiency in that PMRF. Now, another important thing too to know is that the cerebellum will also feed that PMRF ipsilaterally. Okay, so same thing for the other side. The right brain projects directly into the PMRF ipsilaterally and the cerebellum as well ipsilaterally. Okay, so if you have a patient that has a left brain deficiency, then you want to definitely take a look at that PMRF, really right or left brain, and make sure that you restore this before we or early in the treatment plan before you start doing too much eye movements. Now, eye movements can be used properly to benefit this patient, and the way that we would go about stimulating the pons with an eye strategy is using horizontal eye movements. So the eyes move to the left in a horizontal plane, and they activate that left PMRF, or they can stimulate the left PMRF. Now, if you move the eyes horizontally to the right, it would help benefit the right PMRF. Now, when you move the eyes in a diagonal plane or vertical plane, in this case, you are stimulating the midbrain. Okay, midbrain will move the eyes vertically, and it will move the eyes diagonally. And let me put the horizontal one back on here. Okay, so this is a good image to be aware of. Let's take a look at the eye muscles up here, and you will see here that we have color-coded them to kind of match what we're looking at here. If you look at the blue eye muscles here, the superior rectus, superior oblique, inferior rectus, they move the eyes in this diagonal plane. Okay? And the diagonal plane that would be up and to the left and down and to the right specifically stimulate the right midbrain. And you'll see here there's a little red R right next to each one of these letters. Let me clear that to make it a little bit more obvious. Okay, so see that red R there? That red R indicates that these muscles, when you move these muscles in this plane, you're actually utilizing the midbrain on the right side to move in that plane. Now, the cool thing about moving the eyes in a diagonal plane like that is that it's a very specific direction of motion that engages the right brain, left cerebellum, which are hardwired, and the midbrain. And these are known as the Carrick right brain eye movement for this particular plane of eye motion. okay? But more specifically, it would be a saccade up and to the left, followed by a pursuit down and to the right. Okay, so we're talking about direction of eye movement here to specifically target regions of the brain. However, the type of eye movement matters because the right brain, the right frontal lobe, will move the eyes to the left, whether it's diagonal or on a horizontal plane, but it will move the eyes to the left in a saccadic motion. Now, saccadic eye movement are fast eye movement. Okay, whereas a pursuit motion is slower, so as if you were following a target that's moving from one place to another. Okay, but a saccade, you know, the target disappears and reappears in a new location, and your eyes have to move quickly to catch that new location. Okay, so this is the right brain eye movement strategy, which specifically stimulates the right midbrain, right cortex, left cerebellum. Okay. Now, if we wanted to do the same thing on the left, you could see here that we have color-coded the muscles that move the eye in a diagonal plane like this and like that. They are in yellow. So in this case, we would activate the right cerebellum, the left brain, and the left midbrain. Okay, and that's what that L in red signifies here. The L is for left midbrain. And this is incredibly powerful tool to have because you can specifically target a hemisphere or another with these strategies. But again, as I mentioned before, especially if you're planning on doing a midbrain type of stimulation, you want to make sure that you have a PMRF that can handle that type of stimulation. And so oftentimes you may need to do a horizontal strategy first before you move on to a diagonal or a vertical strategy. Now, when you move the eyes in a straight vertical plane, then you're going to actually be using eye muscles on both sides and involving both sides of the brain, bilateral midbrain, bilateral frontal lobe, and that way this is a very helpful strategy, and especially in patients who have like that bilateral frontal demise and they have a camptocormic posture, meaning when you look at their head and their body, you know, excuse my drawing, but these are the arms and the neck, nose. Okay, you can see that their head is anterior, their shoulders are rolled forward, their head's forward, they're in this slouched, forward flexed position. And so in this case, you know, this is your typical frontal posture. You know, you want to look at their sway patterns. When you look at their sway patterns, you may find that their ability to maintain balance is compromised, and they will tend to sway anterior and posterior. Okay, so anterior to posterior. And you will find that with a frontal demise. This anterior to posterior sway is primarily due to the brain's perception of falling backwards. It feels like it's being pulled back, and as a consequence, you know, it's flexing the whole body forward, lowering the body closer to the ground, and giving the body more stability in that way. And so that's typically found with this bilateral frontal. You know, you can have bilateral cerebellar involvement, but basically it's bilateral involvement like this. And these vertical strategies, eye strategies, are very, very effective for that. And we've seen some great positive changes with patients in that way. So now, another thing to consider before we move on to look at the Focus Builder app, now that you have an idea somewhat of an idea of how the vertical, diagonal, and horizontal planes work, you also want to be very aware of what type of eye movement you're using. And is it going to be a reflex, or is it going to be a volitional movement? Okay, so volitional versus reflexogenic. And are you going to use a volitional side here? You have pursuits, you have saccades, anti-saccades, you've got your remembered saccades, we'll call it memory saccades. Okay, and on the reflexogenic side, you've got your vestibular ocular reflex and your optokinetic reflex, we'll call it OpK. And if you've got an impaired volitional function, then you're going to need to use a reflexogenic system to help restore the volitional movement. But if it's the other way around, you may need to use a volitional movement to repair an impaired reflexogenic movement. Okay? So that's why when we test our patients, we always look, how does the horizontal movement, how are they doing compared to the vertical plane? How is right compared to left, up compared to down, but vertical compared to horizontal, and how is the reflex doing versus the volitional movement? Okay, so those are really basic things that you need to understand. In the hierarchy of eye movements, you need to have good gaze stability before you can really use the eye movements beneficially. So we'll say gaze stability. And then the next type of eye movement on this hierarchy would be pursuits, because pursuits are like maintaining gaze on a moving target. And then saccades. And then you get to more advanced type of eye strategies like the anti-saccades and the remembered saccades. All right, those are more advanced. These actually will involve the more executive regions of the brain, so dorsolateral prefrontal cortex and orbital frontal cortex and so on. So let's go through a few scenarios here of using either pursuit or saccade option to have desired effect. So if in my patient here I wanted to do a horizontal strategy and I used a leftward saccade, then in this case I would be using stimulating the right frontal lobe and the left pons. And the left cerebellum will be very useful to make sure that those saccades are accurate and they stop in the exact desired location accurately. Okay, but if I want to stimulate left brain and left pons at the same time, then what type of eye movement would I use? I would use a left pursuit in this case. So if I'm following a target to the left, a straight line here indicates a left pursuit. This would be stimulating or activating the left parietal lobe and the left pons. Okay? As opposed to the prior example, where we're moving the eyes in a saccadic direction, would be right frontal and left pons. Okay, hope that makes sense. Now the cerebellum is very much involved in maintaining accuracy of movement. So when you look at accuracy, think cerebellum, okay? But also when you move the eyes in the diagonal plane, it's much more complicated. and the cerebellum allows you to do things better and faster. And so whenever you do these complex eye movements, such as the diagonal plane, the cerebellum would be involved in a greater fashion. But accuracy and cerebellar function go together. Okay, so again, a quick review. If I wanted to stimulate left brain, left pons, I would use a left pursuit. Excuse my typo. There's U. If I wanted to do left brain, right pons, it would be a right saccades. And that's how we pick the type of eye movement. Now, an OpK stimulation, an optokinetic stimulation, where you have these moving bars on the screen that are going to one direction, to right or to the left. If we have an OpK that goes to the left, then the eyes are going to actually pursue the bar, and then they're going to saccade back to the other direction to catch the next bar, and then pursue again, and saccade again, pursuit, saccade. So an OpK to the left stimulates the left frontal lobe and left parietal lobe. And OpK to the right stimulates the right frontal lobe and right parietal lobe. So these are all the different options that we have in the Focus Builder app. Let's start off with the pursuits here, the very first one at the top left. And we go to settings to determine which direction and type of target we want to use and exactly how we want it to behave. You'll see at the very top we have different directions of movement. So in a case where we want to stimulate the left parietal lobe and the left pons, then we would actually select a leftward motion. You can see the blue arrow there at the top is selected to go left. We have different types of targets here, quite a bit of options from monsters to sports sets. Sports sets would look like this here. If you look up at the top, you have 9 different objects that would be alternated through in monster set, which is great for kids. You can also select your own image. You can upload a picture and have that as your target. Random would be rotating through all the different options that we have in here. Crosshairs is a great one, and simple dot, or target sign, or a simple dot like this, or dot with a black center in it. So let's pick the crosshairs, because this is really the best one to allow you to focus on the center of the target because of the crosshairs factor. Looking at option number 2 is the color. You can change the color here, the blue or green or orange or anything you'd like. But we'll just leave it on red for demonstration purposes. Background, you can pick a variety of different colors. If you wanted to affect the left brain, you could pick yellow. We have textured background, which we'll go over in just a minute as well. We'll keep the dot size as large for now, and the speed. Now, speed is selected as 4 right now. If we've got a patient that has difficulty focusing and concentrating, the likelihood is that they would have a hard time maintaining gaze stability or performing a pursuit, which is gaze stability on a moving target. And so we want with those patients to try to select speeds that are as low as possible, as long as they can achieve the task. With ADHD, patients that have ADHD, they love to saccade really fast in different places, and their eyes are constantly moving around. So in this case, using a pursuit strategy would be very therapeutic for them, and we want over time to work our way to a lower speed. Next option, sinusoidal, basically means that it'll go one direction and return, so it will be bilateral. Repetition here, we'll leave it at 1, but you can select continuous or all the way up to 100. Okay, so let's go back to 1. Initial pause, you have the option here to select tap, which means the target won't start moving until you tap the screen. Very, very useful feature. Otherwise, for now we'll pick 1 second, but you can have as little as no pause or all the way up to 60 seconds. Same thing here, final pause we'll leave at 0. Now, start position. You can have the target begin in the center of the screen or all the way to the edge or in between. So negative will be on the left and positive here will be on the right. So let's start it at 4 here. And we can save it. You'll see at the bottom here it says save as. I've got it saved as test, and we can save that here, and it goes into a separate area where all the saved exercises are. So let's start it so you get to see what this looks like. Yellow background for left brain, left pursuit, which is great for left parietal lobe stimulation and left pons. Okay, now saccades very similar. We have the same directions there, and in this case, let's just say we want to target left brain again. So the direction of movement will have to be to the right, and that's what's selected right now, arrow to the right in blue. Now background, I'm going to change it to a textured background. Textured background is really an awesome feature because in reality, when we look at the world has texture. It's not just a two-dimensional world. There's a lot of depth there. So the texture kind of makes it a little bit more real, or as real as we can make it when it comes to looking at a screen. So we've got the monster selected there. That'll be good. We'll keep that on. Size is 5. Quantity of saccades. This is the number of saccades that you want. You can go up to 10. These would be 10 saccadic movement across the screen. Time interval. That's how much time there is in between each microsaccade. It's random is what's selected there, which is really great. I like that random feature because it makes it really impossible for the patient to anticipate moving their eyes. If it's moving every second, then you can start anticipating when it's going to move. So as the patient gets better, you want to use that random feature. However, if saccades are hard to perform, it's good for them to be able to predict just to help them and assist them. Repetition here, we'll just keep at 1 for now. Pauses, we'll keep the same. Now, stimulus type. You have express saccade and overlap saccade. An express saccade is probably most therapeutic if a patient has a difficult time with speed and initiating the saccade. So to make them faster, an express saccade means that the target will disappear and reappear in a new position. An overlap saccade means that a new target will appear before the first one extinguishes. So the express saccade will help to improve the efficiency of the saccadic system. So it will make our saccades better. And here I selected the sound as bell or water drop or knock, but let's keep it on bell. What that means is here we will have an audible cue that will match the saccadic motion as well of the target. You may not be able to hear it here because of the way that I'm recording this, but you can try it on your own. So this is what that would look like. We started at 0, which is in the center, and then the target will move 10 times from the center of the screen all the way to the edge. And this would be a great left frontal lobe stimulation. Okay, left frontal will move the eyes to the right in a saccadic motion. Now let's take a look at the combination saccades and pursuits. These are also known as the Carrick brain exercises when they're done on a diagonal plane. So we covered that quite a bit already. So in here we've got the target type here selected as sports set. I won't actually explain to you everything that we've already covered, so I'm just going to go ahead and pick a color here for the background. That'll be blue for the right hemisphere, and in this case we would want our saccades to go to the left and pursuits to go to the right. So up left direction here would be perfect. Large random. Okay. Now if we go down to the stimulus type, it'll say initial movement type is saccades first and pursuits second, and that's what we want. Saccades are going to go up and to the right, up and to the left, and pursuits are going to come down and to the right, and that's what this looks like. And we've got a blue background, which is a great option here for the right side of the brain. And here we go, and then it's going to pursuit back down. Perfect. This would be a right brain exercise. Now, we've got random saccades here, which could be very useful if you want to just only stimulate the frontal lobe bilaterally. So in this case here, if I want to have a bilateral frontal stimulation, I could just turn on all the quadrants, and let's say here we're going to make like 10 random saccades. They're going to appear every second. No sound is selected, but we could turn that on, and that's what this looks like. So we're looking at the center, and then saccade, 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 saccade. Keep saccading here to every new target. And so these are random saccades. It could be very helpful to, again, stimulate bilateral frontal lobes. Anti-saccades, one of my favorite exercises. The anti-saccades are extremely useful, especially to stimulate the dorsolateral prefrontal cortex, that executive function area of the brain. This is good for patients who have difficulty with impulse control. So in this case here, I'm going to make those targets be really large, and I'm going to turn off the go, no go, because I just want to explain to this the most simple way of using this feature. Number of dots, I like to keep it at 2, which basically means you're always going to have a center dot that will remain, and those and a lateral dot that will appear either left or right. So, or they're also known as the blinks. I've selected 5 out of 5, meaning out of 10 appearing dots, there will be an equal number on the left and the right. They will just be random. But you could change, or you can use other ratios if you prefer. Interval time is every 2 seconds, and distance I set it at 3. So 4 would be all the way out to the edge, and 3 is a little bit off from the edge. The closer they are together, as we get close to 1, it's easier. Okay. So looking at the center dot here, when you see a dot appear, a red dot appear on the side, what you have to do as a patient is to move your eyes to the mirror location on the opposite side. So exactly where that dot would be on the opposite side. So here I move my eyes to the left, to the right, to the left, and so on. Now if I want to make this a little harder, I could do, so I'm just going to make it a little smaller here. To make it harder, I can turn on the go, no go feature. And I'm going to select characters. So anytime you see a red dot, then you move your eyes in the opposite mirror location back to center. But if you see a different image, it will be a sports image, then you keep your eyes in the center and you don't move your eyes. You just keep them right in the middle. But if it's a red dot, then you do the anti-saccade, which is in the opposite direction of where that target is. And that makes it harder. Now, other ways to make this more difficult is you could increase the speed, and you can bring those targets a little bit further out as well. Okay. Now let's take a look at memory or remembered saccades. This is also an excellent feature to challenge the working memory of your patients. There's a lot of different ways to actually use this application. I'm going to show you my favorite first. So here, as you work your way down, you'll see that that center dot there. I keep that on. I chose the monster set as the target type. Target order, you can do in order, in reverse, or both. And I'll show you what that means here, but we'll just keep it in order to make it simpler. And then I'm going to select mirror. Okay, mirror. Mirror here, upper right quadrant mirror. And that automatically turns off the upper left and right, the other quadrant options, okay? Because I've selected the quadrant feature here, upper right, but you can do hemifield as well. But we'll go upper right quadrant. Quantity of saccades here, I'm just going to keep it to 2 to keep it easier. Appearing speed every 2 seconds, that's fine. Now I'm going to turn this on, and I'm looking at the center dot here, and then I look at the appearing target and back to center, and a second appearing target, and then back to center. As the patient, what I have to do now is look at the center dot and remember where that target was. So I'm going to move my eyes to where the first one appeared, because we're doing it in order, and then with my finger I touch the location of where it was, and now I'll go back to center, and then I look at the second location, and I'm going to get it wrong, so it's red. So now the red is recording that I missed one, so I'm going to go back to center and move my eyes to where that second target was and touch it, and then go back to center. Okay, when you get it right, it's green, but I lead with the eyes first, and then we're going to mirror that into any of the other quadrants. So we'll do one at a time. So I'm going to mirror that into the right lower quadrant now. So I'm looking at the center. Now I look at the first target that appeared in the mirrored location now, and then back to center, and second target, and back to center. I'll do the same in the left lower quadrant. I'm going to look at the first target, back to center, second target, and back to center. And again, first target, back to center, second target. See, I get 9 out of 8. So, I mean, I made one error. Okay? So you can really make quite a bit of changes to this here where if I wanted to, I could do that in the right hemifield. And let's just do reverse order or both, but we'll just do reverse order for now. And so when I start this here, you'll see the first target appear. I look at it and I go back to center, and then I look at the second and back to center. Now I will repeat that in, see, I can't remember where it was. Okay. In reverse order. Okay, I did it wrong. So we got to do it in the reverse order. And then the second one's here. So reverse order, not in order. So that's where I got it wrong there. So now we're going to flip this to the left side, and reverse order was here, and then the next one was here. Okay, so hemifield meaning we're going to mirror what's on the right side into the left side. And this was reverse order. So the reason why I was getting it wrong there is because I was trying to select the targets in the order that they appeared when it should have been done in the reverse order of appearance. So some of the ways to make this harder is you can make the appearing speed faster, and you can increase the quantity of targets that appear. Now this will get really difficult to keep up with that kind of sequence. But you can see how remembering all these here would be near impossible, and then reversing the order. So you start with 1 and 2, and keep adding targets as the patient does better. Now, next feature is the OpK. So the OpK, this is a reflex. The optokinetic stimulation can go to the right, which would be stimulating the right frontal lobe and right parietal lobe, or it can go to the left brain, or it can go up or down for a more frontal type of stimulation. Okay, so in this case here we can modify the color of the bars and change the speed, but just to kind of give you an idea, you can put the center fixation dot on there if you want to add fixation, but I just want you to see here what this looks like. Okay, so that's an optokinetic stimulation. Again, that's just so you can see. This is stimulating the right side of the brain, and this is stimulating the left side of the brain. Okay? Same thing on the diagonal, same as before. This is left. This is stimulating the right side of the brain. And vice versa. So it's really, even if it goes in a diagonal field or a diagonal direction, what matters there is you're doing a pursuit to the right and a saccade to the left, which is a right brain stimulation, whether it goes up in diagonal or down in diagonal. Okay, now hemistim we'll save for a little bit later. When we look at this feature here, the custom feature, it's like what we just covered, except that there's a background option and a foreground option. In the background, you can have a hemistim stimulation, or you can have bars, which is basically the OpK motion, or dots, which instead of bars you have dots that move, which gives you that optokinetic stimulation. You can do that in the background. So I'm going to select hemistim, and I know I haven't gone over hemistim in detail yet. We'll do that after this. But we can, obviously with hemistim the direction of movement does not apply. Let's make it a left brain stimulation. So instead of blue, we're going to pick red and white. Red and white. We're going to make him small, which is good for the left brain, especially the temporal lobe. And I'm going to turn on the right upper quadrant, and it's already selected. And speed, we want that speed to be on the slower end. Very good. Okay, so that is on for the background. And on the foreground, I'm going to make it a left brain type of eye movement. So it'll have to go up and to the right. Sport set selected. It's perfect. That's already on. And I think we are ready to go. We'll get pursuit. We'll make it a little faster. Okay. These are all features we already covered, so I'm not going to explain it. But you'll see that as I'm following that target all the way up and to the right, this is stimulating the left side of my brain. And the cool thing is that in the background, we've got a hemistim stimulation that is stimulating my left temporal lobe. And if this is appropriate for the patient, then it would be a great feature to have, because you've got a visual stimulation as well as an oculomotor type of stimulation. Lastly, I just want to kind of breeze through the gaze stability settings. Gaze stability, you know, if you actually want to see this in more detail, you can see it on our website. We've got lots of videos. But to give you an idea of what this is and why we did it, we did this to give you the ability to customize a strategy to restore the ability to restore gaze stability. If your patient can't maintain their eyes still when they look and fixate on a target, that means that their gaze is unstable. Okay, so you want to test the gaze in the center, you want to test it to the right, to the left, you want to test it up and down. Really ideally in these 9 positions that you see here on the screen. Now, you can help improve gaze stability if, in some cases, if you saccade to a target or if you pursuit to a target, it can help to optimize the stability of the gaze. Okay, so that may or may not work, but just so you know, that's the idea behind doing a movement and then a gaze stability type of exercise combined. So I'm going to remove all these steps here on the right. We'll start from scratch. Now, in this case here, let's say I want to create a step here, and I want to start in the center here. So start target would be number 5, and I'm going to move. Next movement will be to the right at number 6. You know, the classic way to use this feature is in a star pattern. Okay, star pattern meaning center, right, left, up, and down. Not so much using the corners. Target type here, we're going to use crosshairs. and initial pause. I'm going to use tap. I use tap a lot on this this app because it gives the patient the time to do yes, yes, and no, no head motion, which is basically using the VOR to restore gaze stability. Okay, the vestibular ocular reflex to restore the ability to maintain your eyes still. And then final pause, we'll do no pause. And we'll just use the pursuit system, you know, to move from center to right. Okay, so let's go ahead and hit done. So now we've got step 1 programmed, and you can go really to any of these locations, but we'll just we'll repeat that here to back to center. So after you do either right, left, up, or down, you want to go back to the center. And there's always reasons why you may want to do it differently for a patient or another, and we don't have time to get into all those reasons now. But let's see here. So red color, initial pause, again, is going to be tap and no pause. All right, speed 5, perfect. So back to center. And we would do the same now. From 5, we're going to go to 4, which is to the left. And tap. Perfect. And then same thing here. Now we're going to return to the center from 4 to 5. Perfect. And tap again. Okay. Now, just imagine we could also do this here with, well, we'll go ahead and do it, but with the number 2 and number 8, which is up and down. So let's go to 8 next. Okay, tap, done. And then we're going to go back to center, which is 5. And then we're going to add another step here, and we're going to go up to position 2. Which you can't see here. If I raise that up, that's 2, it's at the top. And I'm using pursuits here all the way through, but I'll show you an example of why you might want to use a saccade or and a pursuit in just a minute. Okay, so here we'll go from 2, it's 5 to 2, perfect. And then one last step from 2 back to 5. And I did the final final pause as a tap there because I wanted to hold. So in this case here, the patient is doing no-no motion. So imagine they're looking at the target and they're moving their head slowly side to side as if they're saying no-no while keeping their eyes still on the target, and then up and down as if they were saying yes, yes. Okay, this helps to restore gaze stability. When they're done doing that, they tap the screen and they keep their head in the center while their eyes move to the right. And then again, you do the no-no and yes, yes. Now, how you know and determine how many times they need to do a no-no or yes, yes motion is by watching your patient. If you see any sign of fatigue, or any sign that if you see their eyes are having a hard time staying on the target, then you want to do just the amount that they can do, but not too many, not to the point where they're fatiguing. Okay, again, you do the gaze exercise there using the VOR and a no-no and yes, yes motion, and then you tap, you repeat that every time it stops. And this is how we were to restore gaze stability. Now the cool thing is we're using a pursuit motion here, and the cool thing about the pursuit is it's like maintaining gaze on a moving target, so it's really appropriate unless they can't do it. And if they can't do it, then you would want to do either head pursuit or saccades, or you want to do something that will help enhance the ability to maintain or to perform that eye motion. Okay. So let's remove all these steps again. I want to show you an example of if someone has difficulty performing a pursuit, you could do a saccade before the pursuit, and the pursuit should be enhanced. or vice versa. If they have difficulty saccading to the right, you would do a pursuit first, and then you could do a saccade next. So let's add a step here. We're going to go from 4. Let's say that they have a hard time generating saccades to the right. If you do a 4 and then you go to 5, with the pursuit motion. Okay, perfect, done. And then we're going to do from 5 to 6. At the very top here, you see we can switch it to an express saccade, and we're going to make an express saccade here with no pause. Just make it pause there at the end. And at the bottom here, I could add sound as well. So, you know, sound, that audible cue will make it faster. Sorry you can't hear it in this video. But that's what that would look like. A pursuit to the right, and boom, saccade to the right. Okay? So if they have a hard time making saccades in one direction, you can do pursuit first and then a saccade, and that will help to improve it. When you use the Focus Builder app, there's really 2 different types of stimulation that you can use to help your patients. One is the visual stimulation using the visual pathway, and the other is the oculomotor system in order to control eye movements. So you could use eye movement therapy or visual stimulation types of therapy. So let's take a look at the visual system now. In the visual system, as information comes in through the eye and reaches the retina at this level here, in the back of the eye, it reaches the retina, and the visual information gets transmitted through the optic nerve and through the optic chiasm and then the optic tract, and then eventually reaches the lateral geniculate nucleus right here, and then gets transmitted through the optic radiation all the way back to the occipital cortex, the visual cortex. And once it reaches the visual cortex, at this look at the bottom of the page here, you've got different areas, V1, V2, V3, and V4 of visual processing. V1 is where you have your central vision, and as you make your way closer to that V3, then you've got the more peripheral types of visual stimulation. Once it reaches the V1, V2, V3, V4 area, from there it'll get processed through either the dorsal pathway, which is the wear pathway in the parietal lobe, the posterior parietal cortex, or the ventral pathway, which is the what pathway. We call it the what pathway because this is information that reaches the temporal lobe, and your brain can then determine exactly what you're looking at, whereas the dorsal stream, the wear pathway, gives you better awareness of space. So spatial processing here, as you look at that middle picture, gives you awareness of location of movement and spatial transformation, spatial relations, awareness of space. So, and you need this when you think of it as, you know, when you're walking through the woods, and you're looking at where you're going to put your feet, where you're going to step. That wear stream gives you the ability to determine, you know, how to move through space and what's around you, and gives you that awareness. So it's a much faster types of stimulation. It's a faster frequency of movement, so it really picks up the high frequency movement. Whereas the temporal lobe, where the ventral or what stream is, gives you is really more efficient for object processing, size, shape, pictorial details, texture, color. That would be the what stream in the ventral lobe. Okay, so let's take a look now at our hemistim guide. So we're going to use the hemistim is really our best option in the Focus Builder app to stimulate the visual system. And we can stimulate the visual system without using the oculomotor system. And sometimes that is indicated for patients, but we also have the option to have the HemiStim application play in the background while you're doing an eye strategy. So you could actually use the visual system as well as the oculomotor system for eye movement training at the same time. So when you look at this quick reference sheet, you'll see that we've really divided it into two different categories. There's the parietal and temporal strategy, which is up here at the top, and the hemispheric strategy. So you can put together different types of visual stimulation to either specifically target a parietal lobe or a temporal lobe. So looking at the parietal lobe stimulation, the parietal lobe, as you stimulate the dorsal pathway, visual input goes through magnocellular retinal neurons via the dorsal stream pathway. And these pick up low contrast, high processing speed, colors on the blue end of the spectrum, which will be blue, purple, indigo, larger size images, so big picture. Think big picture, parietal lobe, large, and the lower field of vision. So if you want to stimulate parietal lobe, you want to make sure you're aware of these settings. On the temporal lobe side, when you want to stimulate the temporal lobe, you will target parvocellular retinal neurons in the ventral stream. And so they are in the upper field of view. And higher contrast, low processing speeds, red end of the spectrum, so your orange will be there and some yellow as well. And in terms of size, they pick up more detail, small pictures, small images, details. Now, if you wanted to create a more hemispheric strategy, either for the left brain or the right brain, you'll find that the right brain is very similar to, in terms of the criteria here, very similar to the parietal lobe. They're big pictures, so they respond, the right brain responds better to peripheral field of vision, high frequency, colors blue, indigo, purple, green, which is the blue end of the spectrum. Size is large, again, big picture is better for the right brain, and low contrast. In terms of the visual field, the right brain would be stimulated via the left field of view, whereas the right brain would be stimulated from the right field of view. The right brain is best, we could say, stimulated through the central field of vision. It detects slow movements, low frequency, red color, orange, yellow, small size, high contrast. Okay, now naturally, both sides of the brain can perceive information on both sides here, in both columns. But the reason why we separate it this way is so that if you wanted to pick features that are more likely to stimulate one hemisphere more than the other, then you would follow this guide. So just to kind of give you a little sample of how this could be used clinically, if you had a patient, for example, with dyslexia, and in this case with dyslexia, we know that there's a problem with the temporal lobe, that's where word processing is, and we would want to target that area specifically. So in this case, we want to, in the field of vision, we want to use that right upper quadrant, and that's where you want your stimulation to be. Colors that you would use would be red, and you want high contrast, right? This is what we're looking at here. Red, high contrast. So white is, from white to red gives you a high contrast. You could use yellow as well, but red and white's a good example. small size, the hemistem size, the size of the square, and I'm going to show you this in a second. They're going to be very small. The speed or frequency will be low. On the Focus Builder app, the low frequency are 10 to 12. Below 10 is really ultra low. I mean, we rarely use those features. So let me show you what this looks like in the Focus Builder app. We're going to select the Hemistim app, and under Settings, I'm going to create settings here that are more specific to the left temporal lobe to go along with our example here. So you'll see that the color 1 there, I already selected red, color 2 is selected white. The size is set as the smallest. You can see that you can change the size. There's 5 different sizes. And the speed is set at 12 to keep it low. And again, the upper right quadrant is selected. The other quadrants are turned off. And I also turned on that center fixation dot. And that'll give the patient somewhere to fixate and to look at while they're getting that visual stimulation. You can save these exercises. I already saved it here as left temporal lobe. Okay, so let's start this so you can get an idea of what that looks like. Again, you would have your patient look at that fixation dot there right in the center. And if it's appropriate, you can even have your patient do some gaze exercises while they are getting this stimulation, this visual stimulation as well. Let's give you a different example here. Let's say that I wanted to stimulate we'll go with right parietal lobe. So right parietal, we know that the parietal lobe responds well to the lower field of view, and since it's the right parietal lobe, it would be the left lower field of view. So bottom left quadrant will be on. We're going to increase the speed because the parietal lobe responds better to faster speed and the larger size, so we're going to go to large here. And the color is going to be, we can use blue, and we're going to use a purple as well. So blue and purple would work. There's less contrast that way. And there we go. So we can save it if we want to or not. But let's start that. And there is your right parietal lobe stimulation. And again, here the fixation dot is on. I can turn it off if I wanted to. Now, in this case, those are pretty large squares. We could even use that medium option, which are still fairly decent size, and that would work well. Now, if I wanted to do a right brain or a left brain full hemisphere, let's see here, let's turn on that other left quadrant. So this case here, it would be a right brain stimulation. And I'm just going to change that purple here for, we'll change it for white, or actually gray. Gray would be good. There we go. So this is more of a right brain stimulation. If I wanted to do the left brain, I would turn all these quadrants off and turn the ones on the right on. Slow it down a little bit. Reduce the size of the squares and change the color. Let's pick, let's change it up a little bit. So I'm going to do a red and also do a yellow, just so you get to see what that looks like. And there you go. This would be a left brain stimulation. Okay, so that gives you, I think, a good idea of how to use the app to stimulate the brain through the visual system.